is going to talk about method for sharing a PCI device between multiple PMDs.
Yeah. Hello, everybody. So I'm Fiona Traha, and I've been working on mostly quick assist devices in CryptoDev. But one of the I don't have a. I need there. Okay. So one of the things, just to go with the problem statement. So one of the issues, not so much an issue so far, but in quick assist device we have multiple different functions or services that are available. Symmetric crypto, asymmetric crypto, and compression. So far we've only exposed symmetric crypto through DPDK, and so that's been easy enough to do. But what we did notice when we thought about asymmetric is that the way we would design the API depended a little bit on the underlying hardware. So the underlying hardware in EAL is limited to having one driver for one device. So the probe mechanism on the PCI bus loops through all the for every device first, and then for every driver. And once it finds one driver, it says that one driver claims the device and then owns the device. So if we wanted to do, and this is what's been proposed right by, I think, by Cavium for the asymmetric, and it's a perfectly reasonable way to go about it, but the API for asymmetric and symmetric are in the same, under CryptoDev. And one of the reasons for this is because the underlying device shares the same bar, so the same PCI device exposes two different services. So what this is about is trying to suggest a way that you could share one PCI device between multiple different drivers on the PCI bus specifically, although it might be extendable and probably should consider extending to other buses. Some of this work was done before the bus work. Okay, so in this particular example, what I'm just going to describe is symmetric and asymmetric crypto as two examples of two services. But that's just a generic problem, really, is what I'm trying to explain here. The APIs themselves, the asymmetric and symmetric crypto, probably do belong within the same API. That's not questioning that decision. It's more just using that as a generic problem. So the diagram hopefully will make it a bit more clear. So this is the limitation that we currently have. If you take your PCI, if you take a device which has one PCI, and you put, and you have two different functions in it, and your symmetric crypto, for example, and asymmetric crypto were under two different APIs if you did design it like that, and then you had two PMDs underneath that, and each one registered and said, I can manage that device, the probe wouldn't give the device to the second PMD. It would only allow the first, the symmetric crypto device to get the bar for PCI. And your second PMD wouldn't be able to expose then the APIs that it needed to do. So the current option for asymmetric crypto was to combine both the APIs under the same under the same CryptoDev API. And so you combine them under the same API, and then underneath that you have the same device, the same pull mode driver to run the device. You're sticking with the idea of one driver for one device. And this can work fine. It just means you register, and then on the probe you find your one PMD, and that one PMD can expose the symmetric and the asymmetric crypto APIs. And they are two APIs that it makes sense to include together, but in actual fact when it comes to software exposing the same APIs, it will only typically, you'll have different software PMDs, each exposing, each supporting just or implementing a subset of the API, because really logically they don't really belong together. They've just been kind of lumped together because underlying hardware tends to group them like that. So here's another alternative, is that, and this is what I've done a POC on. You change the EAL and the way it does the probe so that as multiple drivers register, they can register for the same device. And when they register to say that they can control a device, they also say whether or not they're able to share the device or not. And so the EAL PCI probe then, the probe function changes, and once it finds the first PMD, it also reads the flag related to that and realizes that this PMD is able to share the device. So instead of stopping its probe function, it continues on and looks for further devices. And if it finds another device, and its flag is set so that it says it can also share the device, then both of them are allowed to run init functions on that device, and both of them can share the device. And there's a shared data area that I've implemented for the PMDs to communicate how they share the device. But this mechanism doesn't define that at all. It just defines a pointer to shared data. How exactly they share that data is completely dependent on the hardware design. They'll need to cooperate and know if they have to share a CSR, a bank of CSRs, if they have to share memory resources or services. But the advantage of it is that your design of your API then can be decoupled from the hardware design. So if you can manage to share one PCI device with multiple different drivers, then you can choose to put your API wherever makes sense. So if you have two different services that don't maybe logically belong in the same API, then you can separate them out because you can provide your two different PMDs to share the device. Okay, so just the shared data area, as I said, it's really up to the PMDs to decide how to share. I haven't implemented this. A version of this was pushed on the forum a while back, and I think it might have been Thomas that commented on, or somebody commented anyway about maybe implementing something in this into how you share it. And there's something like a reg map which could be done from Linux. There are examples of libraries on how you might share devices, but this proposal is not dictating any of that, and that could be added later. But the examples that I've implemented so far are a shared set of resources. So in our case, the resources would be symmetric crypto, asymmetric crypto, and compression. And then each driver would have to, when it finds the device, choose which service it'll keep, and it'll take all the resources associated with that. Locks to control access to shared CSRs. So in our case, again, there's only one CSR we need to share. Other devices may have multiple CSRs, completely dependent on the hardware design. And state, so if there's something that needs to be done only once by the first driver that finds a device, then that's a good place to share that information, would be in here. So there may be some state. Okay, so where are we at with this at the moment? It works with two of our Quick Assist devices, just in a kind of a demo mode. The symmetric crypto driver runs, and a second, which is also a symmetric crypto driver in my case, runs. We have hit some issues on whether the Ethernet driver can accommodate the changes, and I'm going to go into that in a little bit in a minute. So yeah, there are some tricky bits, as I said, that I had to resolve. The crypto dev uses the BDF string as a name, so I couldn't get, if I had two PMDs and each of them wanted to register the name, then crypto dev wouldn't let them do that. But I just changed the name to use the function. Combined, so concatenated on with the BDF, and that worked fine. The second thing was kind of interesting. Initially, I started off with this as a device attribute, so that a device was shareable, but I thought it didn't work. Well, I thought it worked better, actually, to change it to being the driver. So what I've changed is a parameter. There's already a parameter list, a flag list in the driver, in RTE PCI driver struct, and that is a good place, I think, to add this, because so a driver needs to know how to share the device. So once a driver says it can share one device, well, it would know how to share any other device. And maybe there's a device it can't share, but that's okay, because it can use the shared data area to say, well, I'm sharing the device and I've taken all the resources, so if anyone else comes along, you can't have it. That's as valid a way to use this. Okay, so the last one is the issue that I'm blocked on at the moment, which is that the devices themselves are in a global table. So there's, for every one hardware device, there's one, or for every PCI device, there is one device only in the system. And it contains a pointer to the driver. And it also contains a pointer to an RT driver. So actually, the slides that Ferru presented earlier would be quite useful for this. And the trouble is there's only one pointer. So there's an inbuilt assumption that there is only ever one driver per device. And I've changed that to add an array for one of those two pointers, and I mean, it works fine for my application, but I obviously can't test other applications, and there's definitely work to be done to get this tested and working right, because at the moment I'm not sure how far that assumption is built into ETHDev. So yeah, and the second pointer I didn't change at the moment. I've only got one pointer, and since all the Ethernet devices only aren't sharing, it works okay, but it's not a good solution. Okay, I thought it was worth throwing in this because when I discussed with some people, they said, oh, so you can use it like this. It's not a mechanism for sharing one device across multiple processes. So if you start one process, that gets through the whitelist or through its PCI device list, it gets particular devices. A second process can't use this mechanism to share because the shared data area is within a process. So it's just about sharing a device within a process across two PMDs in that process. Second thing is not a mechanism for making all devices on the bus shareable, as I said already. So maybe one device on the bus can be shared. That doesn't mean the rest of them can. The driver just knows how to share a device if it's possible to share that device. And it's not a framework for handling how the drivers share the device. I've already mentioned that. So this is just saying here's a mechanism so two PMDs can communicate with each other and say we can share this device. How they do it then is separate to this. Okay, quick code snippet here before I run out of time. So this is actually going to the next one first. So at the top line there you see the driver flags. I've added a flag into the RT-PCI driver which is driver can share. And then in the probe function it's looping around, and after it finds the device it simply continues on, checks the driver flag and does it continue here. There's obviously a bit more code to that. And then this is where it gets a bit awkward, is you'll see that the driver, which used to be a single pointer, is now an array of pointers, and that kind of works out okay. But the RT device also includes an RT driver. And as I said, I haven't worked on that yet, but I have seen that it's not used in a lot of places in the code, but it's used in one very important place where there's a copy function that the Ethernet ethdev device copies from a PCI dev, and it copies all the data. And it copies in particular the driver pointer into an ETH device. And then that ETH device is used all over the place. So I'm not sure the impacts of changing it. So anyway, what I would like from you lot is, so this can work, but I'd like feedback from people as to, is this a good way to go? Is it a useful thing? Are there other cases where people would see that? Yeah.
Maybe it would be easier instead of introducing...
Just 1 second. There's a... Yeah.
Okay, over there. Maybe it would be easier, especially for ABI reasons, instead of an array, to have like a linked list of drivers, because you aren't usually going to be traversing it in data flows. It's only during control operations where you have to know who your partner is.
Yeah.
So if you just add another, next device in the device struct,
Yeah.
that might be easier.
Yeah, that should work okay. Having said that, in terms of API or API breakage, as Farah mentioned earlier, with the bus stuff, actually all this stuff is hidden usually under the API. So far, even though I've made a lot of code changes, in actual fact it hasn't hit on the API yet. The RT PCI devices aren't exposed on the API anywhere. Any other questions? No?
Yes.
Okay.
So I think that this approach will be a bit problematic for Ethernet devices. For example, what if one of the PMDs decided to change the MAC of the port? Will it reflect the second PMD? What if he decided to ring down the port? When the device is closed, how is the other PMD knows about it?
Yeah.
So
That's very true. I mean, so fundamentally this is all about sharing devices that can be shared and that have, reasonably separate functions, and there is some mechanism the PMDs can work out. It's not going to enable anything that isn't shareable to be shared.
So I understand the concept about the API separation between the two different PMDs, but what are the downsides in exposing two devices?
Yeah. So one downside I would think, and I'm not sure, so in terms of device I'm talking about, one downside would be that if you stop a device, you obviously have to then manage. If you stop the device, if you stop just one of the devices, what happens to the other device? So, does the order matter? So I think you'd have to, so at the moment there's a detach, and you call a detach per for each of the functions. So same as when you probe and you do a remove, the corresponding remove will call the remove on each of the two PMDs. So if one's still busy and can't, for example, you need to make sure to handle those situations. But again, in the same way as if you're trying to detach one device and it's busy, it can fail to remove the device as well. So I think it's possible to work those, if it's fundamentally possible to share the device.
Yeah, so KVM next generation of the SoCs has similar problem where we have a PCA multifunction devices. So one way what we're thinking, like you can have the main device, then you can have a bus driver on top of that. So that guy can demux the two devices and can have two PCA drivers on top of that.
Say that. I'm sorry, I didn't understand the question.
So you have a bus driver, so that will be registered to your PCA device. So then he's going to do a scan. So he'll find two devices, and he can do two probes, two different devices.
Yes.
So that way, that primary device can function as a resource aggregator or something where every resource allocation will go through that. And other aspect is like if you have an interrupt delivery to the two devices, right? So it can come to the primary device, then he can demux and decode and give to two different device underneath.
Okay. Are you suggesting where there are two different PCI devices though in the same package, or are you?
No, it's a single
Still
PC
the
device
okay.
and some sub-device underneath. So you will have a bus driver, so that will probe the primary PC device.
So you're saying instead that you would actually break the device into two sub-devices within the
Right.
bus structure rather than having
Right.
two drivers support it.
Right.
It's not something I've looked at, but that could be another way to do something similar. Yeah. Yeah.
Yeah, what happens to events in flight? So there must be a whole, with multiple owners, there must be a barrage of events coming back for each one of them, but also everything that's in the queues and maybe copied out of the queues, but in the actual devices. And do you have to do journaling in the application and track what's completed and then replicate that?
So in the devices I'm talking about, which are look-aside crypto devices, we don't have events like that. So there's a lot of things the NICs might have that I wouldn't be familiar with. So from what we're doing, so each of the separate services that in the QuickAssist devices that are available are both quite independent, and it's no different than what we have today where you could have something in flight when you detach a device. So there are, there's a concept of resetting the device. The device can have sessions up and running on it, and you have to make sure they're all finished before you can detach the device, but that's not in any way dependent on the separate services. We'll say compression or asymmetric would be different queue pairs and independent hardware will be running those events. So, but on a NIC it could be different. There could be some things that need to be shared.
Okay, just maybe one last question.
Yeah, so we have the same problem, but a similar one. We are sharing a device, a PCI device having more than one physical port. Mm-hmm. So we have just one PMD. It's not your case, but it's a similar one. So we have found two main problems with this.
Okay.
We have this implemented, but we have two limitations. One is the possibility of attach or detach the device. Mm-hmm. Well, it's mainly in the detach functionality. And the other one is with interrupts, because, for example, interrupts are handled by another driver external to DPDK, and then DPDK is not aware of that kind of. So I think these two limitations can be solved, but for that, DPDK core needs to be modified. So I don't know if you have the same problems.
Well, we do have interrupts possible in our device, but in DPDK we don't use any interrupts, so we have avoided that problem.
You don't have
the physical hardware device could support interrupt handling, but for DPDK we don't use it in that mode. We use it in a polling mode only. So we don't have interrupts that we need to worry about across the two devices. So, but yes, interrupts I think would be certainly one of the things that would be difficult to handle.
Thank you.
You'd have to have a primary and a secondary device maybe and share that somehow.
Okay, thank you.
And that would probably slow things down. So.
Okay, thank you very, very much, Fiona.
Okay, thank you.